What is going on, ladies? Welcome to your 21st chemistry tutorial. At least I think this is the 21st, not positive on that, not proton on that. But anyways, I think it is the 21st chemistry tutorial. Anyways, in this tutorial we're going to be talking about electron capture, my favorite type of capture. So, I don't even know any other types of capture, so I guess this is my favorite. So basically, what the heck is electron capture? The definition is whenever an electron from the innermost energy level, the one closest to the nucleus, gets sucked in or captured by the nucleus. So you know how your nucleus is full of protons and neutrons? It has a positive charge, and your electrons spinning around it have a negative charge. So there's always that attraction, and I guess this is a symbol for attraction, between those two. So basically your nucleus is always trying to suck in those electrons, and once it finally gets one, that's what we call electron capture. Now, you know, a couple tutorials ago I told you guys that you can have a neutron which has zero charge, and it can be decayed, and once it is, it's converted into a proton with a positive charge and also an electron with a negative charge. Well, the opposite of that is also true. What am I talking about? Whenever the nucleus captures an electron, it's going to go ahead and combine with one of the protons that are already inside the nucleus, and it's going to form one of these neutrons. Pretty weird, huh? So a neutron can either decay into a proton and electron, or in this case, an electron is going to combine with a proton to form a neutron. A lot of ons. They need to rename these things so they don't sound so dang similar. But anyways, let me go ahead and show you an example of what's going on. So say you have an element, let me think of an element that this occurs with, like nickel 59. Nickel 59 is written 5928, and the symbol for nickel is Ni. Now, this is the main element, and it's going to go ahead and combine with an electron that was already spinning around it, and will symbolize that 0, negative 1e. Now, whenever this combines, you get an entirely new element. You get 5927, and remember, 27 is the atomic number for cobalt, and you also get a byproduct of X-rays. There we go. So basically, what the heck is going on here? Well, like I said before, whenever you have an electron, it's going to combine with a proton to form a neutron. So since neutrons and protons weigh the exact same amount, the mass of either of those elements is not going to change. However, since we're pretty much destroying a proton and forming a neutron instead, we pretty much turn a proton into a neutron. That is why our atomic number goes down by 1, because the atomic number is the count of protons. How many protons? So you're saying, okay, that actually makes sense in a weird sort of way, but then where the heck did these X-rays come in? Well, remember before when I said that whenever an electron drops down to a lower energy level, then basically what happens is it has to release some sort of energy. So what happens is your electron from the first energy level is going to get sucked in by the nucleus. So that means this electron, or excuse me, this energy level is now missing an electron. So what has to happen is an electron from the second energy level has to drop down to fill the empty space in the first energy level. Whenever you have that occur, and an electron from the second energy drops down to fill the space in the first one, it releases energy. And sometimes I said that it releases photons or light energy. It actually is not visible light like you would think of it. It's actually lower on the electromagnetic spectrum, and I didn't even talk to you guys about the electromagnetic spectrum, but it pretty much releases X-rays, which is a kind of light, I guess. So that is why the release of energy, you also have a byproduct of X-rays in this type of nuclear decay. So to recap one last time, electron captures are basically whenever you have an electron from the innermost energy level captured by the nucleus. Now whenever this happens, it's going to combine with a proton to form a neutron. So that is why you have the same exact mass, because the mass isn't changing. The only thing that's changing is the amount of protons in it. It's -1, whatever it was before, and also since all those electrons are getting sucked in, one of them has to drop down, and whenever those electrons drop down, they release energy in the form of X-rays. So hopefully with that recap, this is now burnt in your brain and you understand what electron capture is. So if you don't, watch the video again or look somewhere else because that's the best I can explain it. But anyways, thank you guys for watching. Don't forget to subscribe. Don't forget to add me on Google Plus and check out my website and donate like $1,000 to me. And yeah, I'll see you guys later.